Evening, my name is Renee Dina, and today I'm going to be showcasing my Project 7 for my CS4310 class, where we are asked to implement a solution for bounded buffers within race conditions. So that being said, first we would examine the code. After that, I would run the actual code and we'll examine the results. So let's get started. So first thing first, we have our public main class. Here is where I initialized everything. So we initialized our buffer size, rounds. I set that to 20. We initialize our limits, where after this time the program ends. Of course, we initialize our next in, our producers next in, and our consumers next out at 0. That will change later in the program, of course. Our semaphores have our initial count equal to 0, and we have a boolean that will be used when the control reaches the last round. And lastly, we have our random set integer. So now we will examine. One thing I would like to mention is that as requested in the actual task, it asks us to create a large buffer size, which we have done, and it also asks us to make sure that the producer and the consumer are on separate concurrent threads within the process. So as you can see here, we'll get to that in a bit. So first, we will look at our producer method. So let's open that. So here it is. First, we have our while loop, of course, where we generate a random integer, and we set that at k1, which is between 1 and half of the buffer size. Yeah, so our k1 is going to be a random integer, which is going to be our buffer size divided by 3, incremented by 1. So here is that. And then I added a for loop that essentially is for I from 0 to our random integer decreased by 1. So that loops over our empty buffer and our buffer index, which will essentially release our buffer if occupied, of course. So moving down, this is where we essentially update the producer's next in. And I did that by adding our random k to our next in, followed by modulo of the buffer's length. I iterate our next inth, and simply to confirm, we output that the producer is okay, followed by the next inth. We update the limit, and we do that by decreasing it. So if we look at the task again, let me pull that up. It asks us down here that if any slot contains a number greater than 0, then the race condition has been detected. So our implementation for that is that essentially we make a if statement that checks if the limit is less than or equal to 0. It'll print out producer exits system without any race problem. So that is that. And then again, if we go refer back to the task asked of us, we have down here that both the producer and consumer sleep periodically for random time intervals to emulate unpredictable execution speeds. And so that is this part here, where we have our thread and we put a sleep for a random int. So yeah, that is our producer method. So now we can look at our consumer method. So let's open that method up. And here is that. So essentially, it's not much different. There's a few changes here and there, but for the most part, it's the same. So our consumer function, we let our consumer sleep for a random integer time interval, as again requested by the assignment. So here is that. We put the thread to sleep for a random integer. To generate our k, we generate it between 1.5 of one third's like of a v1 or the buffer size. So you can see the implementation in this line 93, where we set our k2 equal to a random next int of our buffer size divided by 2. Yeah, and then we iterated by 1. We initialize our data here, and then we have a for loop which is not much different from our producer for loop, which essentially is for our I from 0 to k1, we will then decrease it by 1, which again, we'll just go ahead and cycle through our occupy buffer, and then set our data equal to our buffer's index at the current moment. And then we have another if statement that states that if the data is not equal to 1, it was output to the console, no value available in the buffer. Yeah, so we keep scrolling down here. This is where we update our consumers next out. And we do that by adding our random k2 to our next out, followed by modulo of the buffer's length. Then we output to the console, the consumer is okay thus far, followed by the next out value. Then we update our limit, we decrease it of course, and if we have an if statement that essentially states if the limit is less than 0, we'll go ahead and output consumer exits system without any race problem. And then again, just like the statement or the assignment ask, let me pull it up again. We want to, for both the producer and consumer, we want to produce sleep periodically to emulate predictable execution speeds. So that is this line here at 123, where we have our thread and we put sleep for random int. So that is our consumer function. So now we could open up our main function, where this is essentially the heart of our application. We have our both threads, our producer thread and our consumer thread. So here I just implemented an easy run method that takes advantage of Java's try and catch. So we have our producer. If that runs smoothly, it'll run it. If not, we have an exception thrown, which just prints a stack trace. We go down to our thread 2, which is going to be our consumer thread. Same thing. We try to run our consumer function, and there's a catch. We'll just the exception will be thrown, which is a print stack trace. Down here, we just start both threads, then we essentially join them. So that being said, I have gone ahead and already ran it once. So here's what that looks like. Here we can see that we have our producer first running, says that it's okay thus far, gives our next int of 5, then we have it again, gives the next int of 8, and then we have our consumer thread, which is okay thus far, gives us our next out of that equal to 1, then we have our producer, next int equal to 0, consumer, next out equals to 3, and so on. So here we have our the last exit statement, which states producer exit system without any race problems. So now we'll go ahead and run it again and see what happens. And there you go. So we ran it again. First part, the first few buffers turned out alright. Then we did have an output here stating that no value was available in the buffer, but ultimately it says down here that our producer exit system without any race problem, and so did our consumer, as stated right here in the console. So yeah, that's pretty much the assignment. Hope you enjoyed.